In this video, I am going to discuss another problem in complex analysis. What I have to prove is, I have to prove that the complex plane is not conformally equivalent to the upper half plane. First, I would explain what is meant by conformally equivalence. Suppose you have two domains G1 and G2. We say that these two domains G1 and G2 are conformally equivalent if there exists an analytic one-to-one function from the domain G1 to G2, this is my domain G1, this is my domain G2, such that the image of function f is equal to the domain G2. Actually, this function f is a bijection from domain G1 to G2, and also it is an analytic function. Okay, so and also we know that if a function is analytic and one-to-one, then it is a conformal map. Okay, so that means this map F is a conformal map from the domain G1 to G2, and also that conformal map is going to be surjective. That surjectivity is guaranteed by this condition if G1 equals G2. Okay. Right, so let's move into our problem. I have the complex plane and the upper half plane, and I have to prove that they are not conformally equivalent. So what I would do is, to the contrary, I would assume there exists a conformal bijection from complex plane to the upper half plane. Okay, so I would start the proof. So to the contrary, let's assume that C and H are conformally equivalent. Okay, so what does that mean? Then there exists an analytic one-to-one function f from the complex plane to the upper half plane such that the image of this function f is equal to the upper half plane. Okay, this is by the definition of conformally equivalence. Okay, now I have this map f. So I have the complex plane. This is my complex plane, and I have map simple f visit from the complex plane to the upper half plane. This is my upper half plane. Then I can map this upper half plane conformally to unit disk. Okay, so this is my unit disk. One minus one, and I can map this upper half plane to the unit disk by using this map. So I have some point I on imaginary axis in the upper half plane. So if I use this map, Vz is z minus I divided by z plus I. Then this map phi would map the upper half plane conformally onto this unit disk D. Okay, I would explain about this function phi in one of my future videos. Okay, for now I'm going to use this map. Okay, now let's consider the composition. So if you consider the composition, this composition is capital F of Z, and it is going to be equal to if compose phi Z. Okay, Right. So what can you say about this capital F is it? Capital F is an analytic function from complex plane to the unit disk. So F maps the complex plane onto unit disk. Okay. Now, by the Liouville's theorem, we can say that F should be a constant function because F is entire, because it is analytic in the whole complex plane, and it is bounded because it maps the whole complex plane to the unit disk, and it is bounded. So by the Liouville's theorem, I can say that Fz is a constant function. Okay, what would be my Fz? It would be phi compose Fz is equal to k. Okay. Now I would evaluate derivative of this function in both sides. So then what would I get? Phi prime Fz times F prime Z is equal to 0. Okay. So, but I know that both phi and f are one-to-one functions. So their derivatives cannot be 0. Both phi and f are one-to-one functions. Hence, their derivatives cannot be 0. That means your left-hand side cannot be 0, but your right-hand side is 0. So this leads to a contradiction. So what I have is I have phi prime f of z times f prime z is equal to 0. But on the other hand, as I mentioned here, this cannot be equal to 0. This cannot be equal to 0. This is a contradiction. So there cannot exist a conformal map from complex plane to the unit disk. So C and H are not conformally equivalent. Okay, right. This is the end of my proof. Okay, it is not a very difficult problem, but you have to connect the idea of Liouville's theorem to show that complex plane is not conformally equivalent to the upper half plane. I hope you all understood what I did, and if you have any questions, you can mention them in the comment section. Thank you for watching.